Tintri storage platforms. And what I'd like to do today is talk about the basics of what Tintri delivers. A lot of people haven't seen Tintri VMstore before, and it's been around about 9 years. But just a bit of history again for those who don't know about it is it was developed by one of the VPs of engineering at VMware at the time. And what he did was look at what the real requirements were for a VMware related storage platform rather than using a traditional SAN and just attaching a traditional SAN to that VMware environment. And some of the key things were is, if you've got people that understand VMware and virtual machines, they're going to be more interested in actually managing the virtual machines rather than managing the storage. Also, in the early days, there were a lot of restrictions on how much size you could create a data store within a LUN, and the LUN size was quite small. So people ended up with very large numbers of logical units of storage attached to their VMware environment. So they spent a lot of time messing around managing that. And also then you've got to manage the RAID groups and all the other components within that storage. So the idea with Tintri was to, instead of thinking about it as being a storage environment, just create a data store that's the complete amount of capacity that's within it, and just then use that to deploy your virtual machines and think about it from a virtual machine perspective. So that's one of the first things. So if I jump over to my presentation, so hopefully you can see the presentation, and I'm also in view top right. What we're looking to do is try to ensure that each of the VM workloads has got its own amount of capacity from both a performance and a capacity perspective. So when you put a workload onto the system, what it does is quickly work out how much actual workload it develops this particular virtual machine. So how much I/O activity and how much effectively bandwidth through there that it actually consumes. So you can understand that quite quickly what it actually will consume. And what it does, it continues to look at that to ensure that the workload has enough to actually function. And if you consider different types of workloads, they're all different. Some of them, say a standard server, where may have a particular amount of read-write activity. Something like a DFS server, so using Microsoft's distributed file system, will be quite different because people will be accessing files on a regular basis. So, the actual look of it will be very different to a traditional server. And then if you look at VDI, very much different again, because we'll have a lot of activity initially, especially when people come into work, or as we do at the moment, log in from home, and we get that boot storm type activity. But after that, there's not a great deal of I/O activity because it's predominantly screen and mouse and keyboard activity between the actual thin client or machine that it's communicating with, and then quite a small amount of activity between the virtual machine and its virtual disks there, so quite different. But if you look at something like a database, a lot more activity. So we've got a lot of read-write activity, especially when we've got a database that's ingesting large amounts of data. So it might be used for something like IoT data, or something where there's a large amount of information being sent into it at all times, lots of transactions, or something that actually is being used to feed an application. So maybe a reporting system that's pulling lots of information out of a SQL database or an Oracle database. So again, the workload looks quite different. If you look at a traditional environment, a traditional system, what happens is that that system will treat every workload commonly the same, unless you can actually set some specific, environmental variables around quality of service. And quality of services has been improved with the traditional SAN providers recently, so it's a lot better than it was. But we have to remember this was effectively devised 9-10 years ago and has been in the market for at least 8 years, and has been over that time enhanced and improved. So we get a situation where it doesn't matter what workload you put on it, it will always have enough resources to be able to deliver good throughput and low latency in a virtual world, latency is more important than any other metrics. So a lot of times when we look at storage systems, one of the key things they look at is capacity. So how many terabytes or petabytes if it's a very large platform, or they look at it by the amount of IOPS, so the amount of input-output operations per second the system can cope with. Well, these systems can cope with a very large amount of IOPS because they're solid state, they've got very high CPU and memory capacity within the controllers. So that's not really an issue. But the key thing in a virtual environment is that latency. We need to have really low latency. So most of these systems are sub half a microsecond latency. It's a really low latency. Whereas years ago we were looking at sub millisecond. Some of these systems are sub microsecond. So really, really fast because that solid state nature of them. So that's one thing, giving that ability to give you really low latency and good throughput. So another thing that is really critical and really beneficial, I've covered this before on previous videos, streaming videos, is around real-time analytics. So having the ability to understand what's happening within your environment in real time, but also historic 7 days on the actual array. And if you use the Tintri Global Center, 30 days. And if you look at the predictive analytics from Tintri, up to 3 years, you can see this data. So what we're looking at here is being able to look at the amount of IOPS, the amount of capacity, the amount of latency. And when we're looking at latency, we're not looking at purely the latency of the actual storage system. We're looking at storage, network, and host. And we can actually drill down in the storage and to the host into other components of it. So on the storage side of things, we can see whether it's related to read-write activity, whether it's related to being capped, so throttled back, because it's got a quality of service metric on it that's restricting the amount of capacity it can take. Also on the host side, we can see the CPU utilization, the memory utilization, swap space latency. We can also see the amount of the effect of things like percentage ready for CPU. So the amount of time that the VMware is looking, if we talk about VMware specifically, to actually give workloads to the CPUs. And sometimes we can even identify problems where a virtual machine's been given too many virtual CPUs than it should have. So people can be over generous when they're actually provisioning, especially when they're moving from physical to virtual. They tend to give the same or potentially a little bit more if they think they can speed it up. And actually giving more virtual CPUs can actually slow a machine down. So it can cause problems there. So have that ability to drill down, identify virtual machines that are having latency issues or increasing capacity, large increase in capacity, allow us to identify there's a problem somewhere. If it was last Thursday, we could go back to last Thursday because it's within 7 days on the array, or within 30 days on Tintri Global Center, and look at that issue that was then and identify what the problem was. But we can actually then drill down into understanding whether it's host, network, or storage related, so we can deal with the situation there. The other thing that I think that's quite unique about Tintri's platform, especially the E6000 range, these 6030, 6070 platforms and 6050, is the ability to have them half populated and be able to expand them. So with a half populated system, it comes with 13 drives in there. So the 13th drive is a hot swap drive, so it's sat there just waiting to be used, and the other drives are in use at all times. They're all SSDs. All of them need to be the same size. You can't mix sizes within an array, but you can actually add them one by one. So on the actual application, you can actually do an expansion with it and see how much an extra drive will give you, and it'll tell you the size of the drives. You'll lose a small percentage of the drive size to the actual system, but majority of it's available straight away to storage for the actual data store. So all you need to do is take the blank out, fit a drive or a number of drives, and then you can extend that system with no downtime. So there's no loss of service for any of the infrastructure. Just that happens is your data store gets bigger and all of a sudden you've got more capacity. So imagine you're coming up to 95% capacity, which is realistic with these systems. You can actually get up to 99% capacity and no degradation on performance. It's only when you run out of physical space on there you can't write to that you're going to have performance issues. You can actually then just buy some more drives, add some more drives in, and increase the capacity on that array. So really interesting ways of actually scaling a system. So it's not only just scaling within the array, you can also scale with multiple units as well. So you can add another EC6000 range, or even an alternative range in there. And so if you've got a 6030, you can add another 6030 or a 6050 or a 6070. And when you add them in there, you can actually add them as a pool of resource, and it will actually help you understand where workload should be. And the analytics, especially the Tintri predictive analytics, will give you recommendations on where those workloads should be. So it'll say, well, because of the amount of resources consumed on this box, you better move in this workload to that box. And it will actually do the move for you. And when you actually do that move with a one-click move, what it will do is also take all its history with it. So all that information, last 7 days, last 30 days, last 3 years, will move with it when it moves between arrays. It will also take all its data protection, because as we're delivering this, giving the best performance per virtual machine, we're also delivering data protection at the virtual machine level. So that means we can snapshot with a specific regularity based on that one virtual machine. And we can also create a service group, so we treat a group of virtual machines in the same way. So they get snapshot in the same order and the same time frames. We can also, on top of that, do replication at that level as well. So we can snapshot and replicate that to another system on another site, or another system on the same site, to give us out-of-box protection, actually individually per virtual machine as well. So it's really granular in the way that you can protect it. And again, if you move a workload around, it will take its data protection with it. So it'll move it across with it to the new platform as it moves across. So some really unique things that you get. There is also the database capabilities that I've touched on recently. I'm hoping to get Ross Cooper Smith on the show next week, and we're going to talk about the database side of things and understand a bit more about what you can do with the SQL Server capabilities around protection and replication of those databases. And again, it's per database. It's not per virtual machine or SQL Server. It's actually down to the individual database you can protect at that database level. So much different to a lot of systems that you can do today. Hopefully that's been useful and given you a better picture of what you can do with a Tintri array. I'll just give you generic things. None of our customers who've ever taken a Tintri unit have ever been disappointed. They've always been very impressed by the performance, but one of the key things, it's the simplicity. So not having to touch it, put it in place, put workloads on it, and it just absorbs those workloads and it works. And like some of the quotes we've had from customers is, I don't have to worry about what I put on there. I know it's going to work, unlike our existing SAN. So some particular workloads, they would have to really consider what they did with them. And in a lot of cases, they have to over provision on traditional SANs, whereas with a Tintri unit, they don't need to consider that. Just put the workload on. As long as they know there's some resource in there and capacity in there, they can put the workload on there with no. Okay, well, hopefully you'll join me tomorrow. Ops Ramp Wednesday tomorrow, 3 o'clock again. We do these videos every day. What I'm going to talk about tomorrow is quite business focused around monitoring and management. And with OpsRamp, we've always talked about things like capturing metrics and events and looking at automation and notification. I'm going to talk a little bit more about a hybrid cloud environment and some of the benefits you can get around managing cost. Because I think from the business's perspective, cost has been quite a big issue for a lot of organizations. They've moved into a cloud first policy or strategy, and they've found that sometimes their budget's been consumed in either 3/4 or even half of the time that they expected it to. So there's a couple of things we can do to talk about that benefit there. Anyway, thank you for your time today, and hopefully see you tomorrow.